Little theorem here for you. Theorem, THM. So when I write THM, I mean theorem. So this theorem is a little bit weird looking, but let me show you what I mean with an example. So if I'm doing limit, say x goes to, I don't know, 3 of sine of x cubed. Okay, we're allowed to take this limit and move it inside under certain circumstances. So we can move that limit inside as long as, well, the outside function is continuous at this value. So implied here is that this number actually exists. So this limit exists, meaning it's a real number. Okay, so let's do a full example to see how this works in practice. So pause and copy this example. Now we would like to take this limit and we would like to move it inside. So let's just go ahead and do that, and then we will justify it. Oops, afterwards. So sorry, I want the cosine, and then the limit is now inside. It's the limit of this fraction thingamabob pi. Boom. Okay. So this equal sign is okay if cosine of x is continuous at lim 1 minus root x 1 minus x pi. Okay, so this is fairly simple because cosine of x is continuous on its domain. Cosine of x is just this wave function, right? There's no, just waves forever. There's no, discontinuities or asymptotes or anything like that. So we just need to check that this value here actually exists. Okay, so again, cosine is going to be continuous everywhere. So we just need to check that this thing exists, and we will do that by calculating it. So what does this equal? How can I do this? Well, I can factor the bottom and get a cancellation. I'm going to use my difference of squares. So I got a squared minus b squared is a minus b, a plus b. I'll use that. I'm going to have a is 1, b is, what is b? What is b? Root x. B is going to be root x. So it's a bit weird, but it is a valid factorization. So, factored the bottom. So again, I'm saying this is, down here, this is a squared minus b squared. B is root x. Okay, where was I? Calculating this limit. So I can do my cancellation here. I get limit 1 over 1 plus root x. The perceptive student will notice I forgot my pi. I forgot my pi here. So I'll stick it in right there, pi. Here's my pi. Now, what's x going to? X is going to 1. X is going to 1. So what do I get? I get a half pi. A half of pi, better known as pi over 2. Okay, so cosine is continuous everywhere. So it's certainly continuous at pi over 2. So this limit up here can be calculated. No problem. So we get cosine, and this limit we found to be pi over 2. Cosine of pi over 2 is 0.